and approximately 2.69 million kilowatts per hour. Next is solar energy. Solar energy is radiant light and heat from the sun that's harnessed using solar heating, solar thermal energy, molten salt power plants, and artificial photosynthesis. And we would use the empty space to make some kind of solar panel form, like over there. Batteries can also store energy, but it will be more costly. Next we have geothermal. We would drill deep into the ground and create pipes so we can dissipate heat from our cooling systems. Geothermal is basically used to pick up heat and have it dissipate in the ground. And this can be used through a cooling tower. It generally doesn't give power, but helps cut down on your usage. Finally, we have biofuel. In a landfill area, we can collect methane, and instead of having it pollute the air, we could collect it and use it for energy. We then compress it and use it to run a generator, which is used to create electricity. All in all, these we interlock these power sources in a common grid. Here's Patrick.
Hi, I'm Patrick, and I'm going to be talking about the different types of farming, which is aquaponics, hydroponics, aeroponics, and indoor gardens. So aquaponics is the way aquaponics works is a system which water recirculates from a fish tank through a vegetable growth bed. Nutrient from the fish waste feed the plants. Plants filter the water to keep the fish healthy. And for hydroponics, it's a method of growing plants in nutrient-rich water, and it does not use soil, and it uses less water than soil-based plants, and also better for the environment because it reduces waste and pollution. And for aeroponics, more oxygen equals more growth in the plants. Nutrients delivered by the fine mist only requires a little bit of water, and roots are exposed to the air and not blocked by dense soil. And for indoor farming, it says it in the name, it's growing indoors, requires much less water than outside. Most plants will grow between 65 to 75 degrees Fahrenheit. The blue light encourages lush vegetable growth, and the red light encourages flowing water. And to protect Maunabo, we came up with a strategy which is berms and erosion control. And research has shown the compost can often outperform conventional slope stabilization methods such as hydroseeding and hay straw mulching. The compost layer absorbs the energy of the rainfall, which causes the movement of soil particles and substantial volume of moisture, as well as reduce its flow velocity, improving percolation rates. Typically, a screen compost is used to build the filter berms on construction sites and gradual slopes, whereas a coarser mulch is used on a more severe slopes, and this allows water to pass through. For wetlands, to sum this up, they protect our shores from wave action, reduce the impacts of floods, absorb and improve water quality, and they provide habitat for animals as well. And wetlands, we decided to put wetlands on that blue area there. We would want to put it there, and these on the green side, it was already existing there. Wetlands were already existing there, and that's the breakwater. This is how wetlands work, which is the stream energy. Like the water comes down into this puddle here, and it's like a way of an ecosystem is already growing there. So it comes out with clean water. And this is another example of a healthy wetland. And we decided to make it more, I guess, creative. We made it a park, so it could be like for people, the public to come and see it, and it will be for both the public and it'll be something good for the environment. And yeah, that's it.
This is basically the same thing, just a final plan. For the building infrastructure, we're going to use cooling riser, and this basically this distributes chilled or cold water throughout the building, and air conditioning. It's used for air conditioning. This is the same thing again, except it's utilized by solar panels and uses the sun, so it's more efficient. And this is just a regular air conditioner that pumps the heat out. And the way it works is cold air from the inside comes in through the blue, and it's essentially the water is filtered out in the center, and then it just comes out into the atmosphere as the cold water comes in. I mean air, sorry, cold air. And so the elevators that we're going to have inside could regenerate power. Essentially, when the elevator is full and it's coming up, it generates power, and it's when it's empty and going up as well, it generates power that can be used throughout the building. And the electrical distribution, the power is utilized through the conduit wire that is used and distributes power throughout the whole building and each floor. In the event of a power failure, automatic transfer switches will transfer the load to select panels, and it will power the exit and the stairs, lighting the stairs. Since we're going to use LED lighting inside the buildings for more efficiency, and shade control, shade is operated automatically based on the time of day, which provides another energy source.
So overall, our project makes emphasis on 3 areas, and that's sustainability, community, and resilience. Sustainability in the solar, wind, biothermal, hydro, and biofuel energy. Community in the spatial allocations of different programmatic elements, and resilience in the building strategies and mechanical systems. That's our team, and we'd like to thank our mentors, and we're running late. Okay, cool, thanks.